Good. Can everybody see my screen? Thank you, Joy. And so what is this about? So we may have talked to you already about like trying to build an open source ecosystem for computational knee biomechanics. We actually started these conversations like as part of our National Science Foundation grant. And that is really Snail Chokandra is doing. And I was like tagging along. And then we were able to meet like more than 60 stakeholders in knee biomechanics that may be in the experiment side, that might be heavily involved on the computational side. And we really learned a lot from you. And we were not necessarily focusing on the science or on the knowledge, but more about what do we need to do our discoveries, innovations, and translation of knee biomechanics to clinical care, like how we can all connect together. And that was our like scoping activity. And as a result of that, we really thought that a webinar idea where we can all get together. So rather than us talking to each one of you one by one, maybe we can start having these conversations like all together. And we can really understand collectively what our ecosystems looks like. So, and after our conversation, Snail actually made this like very kind of a confusing, but also to accept people in the meantime, by the way, sorry. And this is actually the ecosystem that Snail generated. Okay, and please be muted when you're coming in. And this ecosystem is not just us researchers. Like it involves medical device industry, it involves funders, it involves FDA, because we are like touching like knee biomechanics and knee modeling and simulation in discovery in orthopedic science and in innovation in medical devices or clinical care. And this is what we felt like how we may be connected to each other and how we may support each other. And we will be happy to share these slides and then also share, this ecosystem like plot with you too. And I believe many of us fit in one or more of, these boxes or like the arrows that connects these boxes. And that's why like we really wanted to dive deep with these webinar series about who is actually in which box and what they provide and like what are the platforms, technologies, infrastructures, resources that they create or they may be willing to share or they may be willing to enable with their expertise, like to really propel knee biomechanics further. And so far we have a schedule of like 4 seminars, and we are like starting this with Joyku from Stanford University. She will be talking about like SimTK. And in April, we will have the Knee Hub group, Jason Halloran and Kalim Hauser, talking about more workflows, and that relates to art and reproducibility of knee joint modeling and simulation. In May, we will have Ruth Wilcox and Alison Jones from the other side of the Atlantic Ocean to hear about the data and models that they created, like, and that are also available, like, for to enable many of us. And we will also have Kevin Mormon joining us in July to talk about open source modeling and simulation tools that may have some relevance, like for knee modeling and simulation. So we are hoping these webinars to be a tradition where we are hoping that they are not more like lectures, but everybody can learn something and something about a resource, something about an exciting finding maybe, but we can then like really also like, tell people about what kind of resources, what kind of like activities that we have in knee biomechanics that might benefit the whole community as a whole. So if you have any recommendations of who you want to see, or if you want to like present, please reach out to Snail. Her email is there at chokas@ccf.org. So I will stop here and I will pass the torch to Joy and start talking about SimTK. Thank you.
Right. Thank you so much, Amit, and thanks to you and Snail for organizing this webinar series and bringing us all together. As you can tell, I am recovering from a cold, so I hope you all will bear with me and help me take some of the load off of me and actually make this a really good and stimulating discussion, rather than just, as Amit said, just having me lecture to you. So let me go ahead and share my slides here. You able to see that, Amit?
Yes.
Right. Um, so there are four main areas that I want to try to cover today, and we'll see how far we get, given that we do actually want to have some discussion as well. So first of all, for those of you who aren't familiar with SimTK, I want to talk a little bit about what SimTK is, and I'll share examples of how the knee modeling community has been using SimTK, talk about some of our more recent features that we've implemented, and then talk a little bit about where we are headed. And this is the part where I think a lot of you, I'd love to hear from you to see and hear what are the needs, because the needs are going to drive what we do on SimTK. So SimTK was actually launched 20 years ago, back in 2005 by Symbios. Those of you who remember, to that time, the NIH had a program called the National Centers for Biomedical Computing, and Symbios was one of those centers. The software team for Symbios looked around the software computing landscape, and they were really looking for a way to work together really well, and they didn't find much. It was a desert out there. There was nothing that really met their needs. Their needs were rather straightforward. They wanted to collaborate with others remotely. They wanted to easily share and archive the data, software, and other resources they were developing. And they wanted a level of control to determine who could have permissions to view and access what they were working on. And if you think about today, that landscape is very different, but all the platforms we're familiar with from today just didn't exist 20 years ago. No Figshare, no Dryad. Google Drive didn't launch until 2012. Dropbox, that idea hadn't even come up yet. And GitHub was 3 years away from actually being launched. And so the Symbios team created SimTK just so they'd have this platform that met their needs. And it turned out that SimTK was also useful for other research groups. So what is SimTK? For those of you who aren't familiar with the site, it's a web-based project hosting platform that's really built for the biomedical computing research community. And we really, if you look at that tagline up there at the top of the site, the goal was to enable groundbreaking biomedical research via open access to high quality simulation tools, accurate models, and the people behind them. And you'll notice I kind of added here in red this and data. As time has shifted, we've realized that data actually also plays a very important role in our modeling and simulation ecosystem. So anyone can sign up for an account, create their own project, which they independently control, and they can share their software models data with whomever they want. It's been extremely useful, especially for those who don't have the means to build and support their own websites. So to date, we've had over 4 million files that have been downloaded from SimTK. There are nearly 2,000 projects hosted on the site, and over 160,000 individuals have signed up to have access to the site. Now, there are two qualities I want to emphasize about SimTK. One is its flexibility. SimTK doesn't have any requirements about file types, metadata, and this makes it really suitable for diverse disciplines and applications. So we have molecular dynamics projects on there, cardiovascular simulations, obviously biomechanics, musculoskeletal types of simulations as well, rigid body, finite element simulations, imaging, more computational simulation, kind of that whole gamut. And the other quality I want to emphasize is that SimTK was really built around that idea of community. We didn't want a one-way street where people are just posting a resource and others download and use it, though it is often used that way. If you remember, the original goal of the Symbios development team was they wanted a platform to facilitate dialogues, to foster connections, and SimTK was designed with that in mind. So I'm going to give you some concrete examples of SimTK projects to better explain, give you an idea what SimTK is and how it can be used. And I'm going to do that within the context of the knee modeling and simulation community because that's why you all are here. So one of the first projects I want to highlight is the Grand Knee Challenge. It's a challenge competition to predict in vivo knee loads. And this was developed by BJ Fregley, Daryl DeLima, and Tor Bezier. Got together and they provided this really unique and comprehensive data set that was shared along with a challenge to the research community to try to predict muscle and joint contact forces in the knee. They had tibial contact forces that were actually measured from an instrumented prosthesis. And that was kind of the hidden information that people were trying to predict. And that was used to judge the competition entries. Their project took advantage of SimTK's flexibility, and they were able to share the data via the download section, which was, as you recall, was originally intended for sharing software models. They used the forums and mailing list to allow for community interaction and took advantage of the statistics as they reported their outcomes. So if you're interested, you can, I'll share this on my screen, but you can also jump to this website. Hold on. Down here at the bottom, https://simtk.org/projects/knee loads. But I'll also take you through it on the screen itself. So this is what a project page looks like. You have a little bit of description about the project, some basic statistics about how many downloads, how many forum posts, how many people are following, who the key administrators of the project are. And then they put all their data in this download section. So up here, every project has a navigation bar that they can customize. For this project, they had all their data here over in the download section. And anyone who's logged in, or in this case, not logged in, you can go here and you can click on something and it'll ask you to log in. Oh. And if you log in, what you get is questions about how you're going to use this software. There's an option to sign up for their mailing list and then a license agreement, and then you can choose to download or not. So as I mentioned, the two community building aspects, oops, it doesn't like it when I skip out there. The are the mailing lists here. So we have a mailing list that people can sign up for, and it's a way to share information with whoever signed up. So if you click over here, one of the last ones that BJ sent out was information request for their final report for their NIH. So great way to reach out to those people who are using your tools. We're having. So as I pull the screen back up, are there any questions so far?
So Joy, maybe I will ask a question, like as you move on. How does SimTK, and I believe you might get into this a little bit further down the road, is like because the data sharing and collaboration environments changed dramatically since SimTK started. But what makes it SimTK still special, like compared to Zenodo or compared to Figshare, like more other repositories that we might be familiar in the nowadays?
Yeah, I'll talk about that a little bit more. I think the community aspect is one
Okay.
piece of it. There's a lot of
I said some of that stuff in the video, but I can put it in.
Hold on. Here, I need to mute people. Can you repeat the answer again, Joy? And we also have a hand raised.
Okay. Like I said, one of the pieces is this community aspect where there are a lot of tools in terms of being able to connect with and build community that I think you tend not to see within one framework of a repository. A lot of the repositories are more about putting your tool up there and then people download it. There's less ways to do the interaction. And I think the community that itself that we've built on SimTK, where this is a place where those of you who are doing biomechanics, especially in musculoskeletal simulation, that this is where you come. This is where a lot of the models are.
And we also have Alison Jones. Alison, do you want to turn on your camera, say hi, and ask your question?
Sure. Hi, Joy. Thank you very much. Just a really quick aside before I ask my question. I don't know if this is true for other people, but for me, I can't get into the chat. It says the chat is only available during the meeting, but we are during the meeting, so I don't know what's going on there. But if that's true for other people, maybe you're missing out on great questions.
Yeah,
I know somebody can post, so maybe it is just me.
It might be because of our organization's security policies, but again, if you just raise your hands, I will, call you out. Let's do it that way.
Well, I am very dodgy, so yeah, that's probably better. Yeah, so I was the Knee Challenge project is a great example because it's clearly designed from scratch for engagement. It's asking for people to come along and do something with that project. And I wonder how many examples you've seen that have that sort of design from scratch and whether you think to really get engagement to work, we have to almost think about what we're putting up with that in mind. Why would somebody interact with this?
I think there's different levels of interaction that you could have. So for instance, if you're a developer, I think GitHub's the place to go, right? You have a whole development community that's really meant for developing and working together on source code these days. If your audience is a more general audience who may not be so interested in software development, other platforms might be more suitable and have better tools to support that a different audience. And so I think when you are creating a project, it does help to think a little bit about what is the purpose and who is your audience, because based on that, you may want to use a different platform and have different sets of content that you're sharing. So that would be first point, is to think about the audience and who are you trying to reach. I think that's true for anything that we do. The second thing is for SimTK at least, and I think probably for other repositories, that there is this option to kind of flip between private and public so that you can hide things and use it more like a research stage project, which just you, maybe two of your lab mates that you're working closer together on, things can be a little bit messier. And then either create a new project that has things that are better suited or better designed for dissemination, because I think it does take some thought if you want to really engage a broader audience to do things well so that people can find it easier. If there are barriers, people have a lot of choices these days. So if they run into barriers, they're going to jump somewhere else. And so making things easy. And you could either flip your private project and clean things up there and then turn that into a public, or just create a new project. I guess that's one of the things with a lot of these free platforms is it's very easy to just spin up something new. Does that answer your question?
It did, yeah. And I think I like because one of the things we've discussed, I think, with Ahmet as well, when we've met him before, is around the challenge of just the effort that it takes to get data and models into a state where you feel happy to share them with other people, or indeed that anyone would really understand what you've done. And so having that idea of an intermediate stage where maybe you're still only sharing that data with people in your lab or maybe immediate collaborators, but it's up there and people are seeing it and thinking, we need to improve this before we release it. Maybe that stage is actually pretty good to have there. Thank you.
Yeah, I think that makes a lot of sense. And actually the next project that I was going to talk about is Ahmet's Open Knee project. And I think Ahmet might be able to comment a little bit about even how he used that project, because it's very nicely set up for dissemination. But I think he staged things elsewhere. Is that right, Ahmet?
Yeah, I can talk a little bit about it. And Joy, you're not sharing your slides at this moment, by the way.
Yeah, I can
okay.
jump to the slides if.
Yeah, and I can comment
okay.
with the slides. Yeah.
Okay. So Open Knee is the other project that I wanted to share with the group. This is from Ahmet and Snail. And I think it's a really nice highlight of how you can use a project. Ahmet's had a lot of feedback for us about what his needs are for sharing. And you'll see some of that in this particular project, which uses a lot of the different features of SimTK. So one of the one of the differences between this project and the other is that Ahmet's worked with us closely on this data share view for our projects. So as I mentioned, originally the downloads section was set up so that people could share software and models, and it's great. You know, you put a software package up there, people click download and they get that license, and click to agree and they get the file. With OpenKnee and the increasing use of wanting to share data, we felt there were additional features that were needed. And so we created this data share feature on there in collaboration with Ahmet. And so Ahmet's got models, and then he's also got his data shared through this. So what you can see here, let me make this screen a little bit here, is he's got something like, whatever, that's 21 folders. Each one is for a different subject. And so I think this parallels a lot of the way we collect experimental data as subjects, and then you have all the data related to it. And what's nice about this versus the traditional way is you can actually browse and go into the data itself. So, you know, I can see a subject has derivative data and it has raw data and it has a metadata file. And you can dig in. What is in that raw data? Well, there's joint data and there's MRI data. And so that's really nice about having this data share view of what's being shared. The other piece that's really nice about this is that you can query data. So if you have metadata files associated with all your data that you've uploaded, you can go through and say, well, out of that 21 data subjects, I'm not interested in all of them. I really only want those where the age is, say, greater or equal to 50 years old. You search through and it's like, okay, well, only 4 of the subjects, 1, 2, 6, and 7, actually match that. And then so now instead of having to download all the data, I can just grab that subset. So this is something that we designed with input from Amet, and it's turned out to be useful for others. It's a really nice way to share your data and allow people to query and explore your data set. The other features that Amet is using on this project really have to do with interacting with the community. So in addition to using the forums, there's also a wiki that he's taking advantage of, and he's got news. So he puts up every so often announcements about what's happening with the project. And so these news items appear on the project site. It also appears on the front page of SimTK. And anyone who's following the project gets these updates. So you can see, we can look at the followers. And in this case, this project has 47 total followers. Some of them are public and some are private. And what it means if you're public is that others can also find you and know that you're following the project. And we actually created this in response to our own needs, where we were having users come to and ask us questions, and they'd be like, we are the only one at our institution who is working on this type of project, this type of technology. And we're so lost, we could really use some support. And what would happen would be they'd get together at some of our meetings and they'd be like, oh, I met someone else who works on my campus. They sit on the other side of campus. I didn't know they were there. And so this was a way to allow people to discover who else near them might have similar interests. So in this case, if you're a public follower, you can click and it's like, hey, there were 2 individuals at University of Malaga who are working with the Open Knee project, or at least interested in it. The other piece that we've built into SimTK to really allow people to make connections is this part down here. There are a couple pieces here. We have a related projects section where you can start to connect different projects together. There's a people also viewed, which is a recommendation engine similar to Netflix. People watch this, so you might also be interested in it. And then at the top, we have these communities. So these are collections of projects to bring people together to say, here's all the OpenSim types of projects using the OpenSim software or the SimVascular software. So you can imagine that you could have a knee modeling community and pull together news and project updates all in one place.
Maybe Joy, do
yes.
you want me to relieve you a little bit and talk about my experiences?
Yeah, that'd be great to hear a little bit about how you use this in addressing Allison's earlier question.
Yeah, because I think it is important, because as a knee researcher, I think I really didn't want to also be a data management expert at the time. And I think that was why working with SimTK and Joy was very fruitful for us, because there are actually the needs for data collection and model development are a little bit different of using and analyzing the data or using and analyzing the model results versus disseminating them afterwards and publishing them. And I think that so there's a temporality, and there are different data assets, or different assets like data, documents, and model. And I think that's where SimTK was very helpful for me, because during the development, we were using Wiki a lot because we were writing all our specifications of how to collect data, how to models like in the Wiki, and then keeping alive documents there. But then as we actually started to generate codes to build models or like the models themselves, we were using the code repository, but also like the download section and the data share section like to populate. And Joy will talk a little bit more about it in a moment, I think about. And at the end, once we are all said and done and we want to forget about the project because we published, we would create a DOI with all our assets, digital object identifier, then we will ensure longevity of the data and more or less actually the SimTK was gracious enough to commit to the long-term sustaining of like the availability of those resources once we get the digital object identifiers. And I think, and that is becoming more and more the norm. As we were doing it, it was kind of an exception, but now I think all of us are being expected to do things that way. So that's my 2 cents.
Thanks, Amit. Yeah, and I will touch a little bit on the DOIs and some of the other efforts there. So in total, right now on SimTK, I went into the search and I typed in, excuse me, knee, and I came up with 163 projects. And I was just curious what sorts of projects they were. Most of them are models, and they vary. Some of them are just lower limb models, whereas others are just models of the knee. Most of them are human models, but there are also some models that are referencing animal hind limbs. We have some software-related projects, and this varies from software for image in terms of image registration, image segmentation related to the knee, statistical shape modeling, all the way to the other end where there's simulations or plugins for modifications to simulations, analysis tools to extract out information from those simulations. And then we also have a few projects that are providing data. And again, this spans the gamut where we have imaging data, as well as your traditional biomechanics data, mocap, EMG, and then data from some newer modalities like IMU, or in this case, what I'm showing here is capacitive sensors, which is a project from Eni Haleha at Carnegie Mellon, where she's looking at using capacitive sensing for understanding biomechanics, and actually includes gait data from a total knee arthroplasty patient. So before I jump on and talk about some of the newest features of SimTK and how that plays into where we're taking SimTK, wanted to see if there were any questions about what I've shown so far about SimTK and how people have used it.
And maybe I will ask in mini voting too, like, how many people have already used SimTK in here will be interesting to know, I guess, and then what they might have as a feedback, what worked, what didn't. We have a hand raising by Amy Morden. Amy.
Sorry, I'm just gonna just add to the conversation. Your question was very on point. We have hosted some wrist biomechanics data, and lots of like a large comprehensive collection from various different research studies. And we're actually also trying to initiate something that's very separate to this as a hosting repository for biplanar video radiography data. And that's coming out of Dr. Beth Brainerd at Brown University. She's got heavily involved with the ZMA, or zoological motion analysis kind of group. They've been doing some great work, but I actually screenshotted while Joy was presenting, because the querying functionality in Open Knee is exactly what we're endeavoring to develop at the moment. So you guys are definitely a step ahead. So I'm definitely going to go back to our group and say, we are somewhat reinventing the wheel. on our newest venture, and that there's quite a bit of surplus of both implementation and experience already in SimTK. So just a thanks for the work so far. There's, yes, we're users, but I think that we also have further use cases in the future, and we'll be reaching out.
Thanks, that's great to hear. And I think one of the things that I'd like to do better is to reach out to existing users and to find out, as the whole data modeling landscape is shifting, how are your needs shifting as well? And we'll talk about that at the end when I get to the what's next, is we've built in this data sharing feature. Matt was at the early stage of, he was predictive and able to see into the future and knew that this would be useful. And we'd love to hear what are some other capabilities that would be helpful to the research community. One of the things we have been doing is really pushing forward on this idea of open science and making everything available. That idea of open science, it's been around a long time, I think, but more recently with the White House and some of the NIH Office of Data Science forming, the White House called 2023 the Year of Open Science. And so we've been implementing and trying to align with some of the efforts that are going on out there in terms of open science. One of those Amit mentioned was providing this idea of a digital object identifier, which is a persistent identifier. For those of you who aren't familiar, the idea is that you have this number or this link, and that that link is going to be live even if the underlying host platform goes away. So we've committed that we will always make anything that has a DOI always available. And whether it's from SimTK, if SimTK should go away, there's a backup plan to have it shared elsewhere. So that even if the underlying platform goes away, there's a way to access these resources. ORCID IDs are another type of persistent identifier. This is for a person. And what it does is it links the person's publications and other scholarly outputs all together to this one persistent ID. So if you have one, you can actually add it to your SimTK profile and it will appear with your SimTK profile. And so people can see, here's all your SimTK projects, and here's also all the related publications and other outputs, research outputs that you have. Another concept that drives what we do here at SimTK is the idea of the FAIR principles. So making things findable, accessible, interoperable, and reusable. So I think just based on what SimTK is, we're automatically kind of doing really well in terms of the findable, accessible, and reusable. So we provide metadata, we have the persistent identifiers. Accessibility, as long as your project administrator, they're able to set permissions to say who gets to access what. And reusability, we're providing metadata and making it possible for project administrators to provide documentation so that whatever they share can be easily reused. And one area we're really working on is this idea of interoperability. So in terms of connecting to the larger data and modeling ecosystem, one of the things we've already implemented on SimTK is a connection to the Google dataset search. So I don't know how many of you have actually used Google dataset search. The idea is that they provide a certain schema and that pulls in consistent information about all the data sets that are out there on the web, and you can then search it through this dataset search.research.google.com. So if you go there now and you type in Knee model, you'll find that SimTK projects occupy the top few search results there. And so if you're putting things on SimTK, it's going to automatically, and it's public, it will automatically appear in the Google dataset search. The other platform that we've connected to is GitHub. So GitHub is this repository with hundreds of millions of repositories and really well known for co-developing code. If you have a GitHub project, you can link that GitHub project to your SimTK project. And so people can, in one easy place, get access to all the pieces, your source code for that project. We've also set it up so that we will automatically pull information from GitHub, and we can make it available as a SimTK download and refresh it on a weekly, monthly, or whatever frequency you need, so that if you know you're consistently making updates on GitHub and you want it to automatically appear within your SimTK project, you can do that and set that up. So I think that's a good segue into what's next for SimTK. I mentioned already, that we had this interest in connecting to the larger data and modeling ecosystem. And that ecosystem has grown tremendously, includes many other players than Google and GitHub these days. So NIH, as you all are probably aware, has really put forward a really strong effort in terms of scientific data sharing. Their website lists over 140 different repositories. A lot of it is genetics and genomics and protein cellular level focus, but there are repositories that are broader. There is also the Open Air effort, which this is a European group that is very interested and has done a lot of work in terms of open science infrastructure, including running the Zenodo repository that Amit mentioned earlier. For those of you who are doing machine learning, you're probably familiar with Hugging Face, which is a popular platform for sharing AI models. We use Google Colab a lot, and this is a really helpful teaching kind of tutorial dissemination technology based on Jupyter notebooks that allows you to create this interactive notebook where you can ingest data and models and run code on the fly. And of course, there's our base software packages that we've used, and I think you'll have a speaker on later in this webinar series talking about tools for modeling and simulation, OpenSim, FE-Bio. And so question for us is, out of all of these, there are a lot of things that we could connect to, and which ones are important, which ones are you all using, where it would be nice to move data or resources from one to the other. I'd love to hear some feedback from the group.
Fine. Any comments from the community and from all of us?
Sure. Yeah, this is Jason Halloran at Washington State. Joy, I would just say integration with a couple of these things, probably in particular GitHub, which you guys are working on, would be hugely valuable. A more seamless integration between code development and then it showing up on our project sites would be really great.
Yeah, I'd love to chat more, and we could dig into, what does that actually look like?
Sure, happy to.
Other thoughts, other tools that you all are using, and whether or not you're thinking of having it connected to SimTK or not, but just tools that you use that you find very useful, and maybe connection to something else other than SimTK.
This is
Oh,
sorry. This is
go
Rob
ahead.
Colburn. So yeah, our use for this stuff is more because we're essentially generating data, biomechanics data in vitro testing. So using it for ways for people to share the data that gets collected in a way that's searchable. So like the data query stuff, and that is definitely very useful. And we have a international spine kind of biomechanics study going on right now that we basically, had these spine circuits. We shipped them to 7 different labs around the world, and everybody took the same data, and we're trying to compare them and see if our techniques for taking data are similar and stuff like that. But as everybody's data is a little bit different in how they present it, and so trying to get everybody to get that data and formulate it in a way that's searchable and common is a challenge for us. And then we've also had conversations around like where do you host it, and so we don't have a solution for this yet. I know Amy, you mentioned something about where you host stuff and where you put it, but so I'm definitely interested in learning about these types of things.
Yeah, we've thought a lot about the data sharing piece, and I think we're thinking a lot more kind of as these data sets get larger, how and if it's appropriate for SimTK to grow to support some of these huge data sets that get generated. When we were talking about software and examples, a couple 100,000 megabytes would be plenty per project, but now we're talking about terabytes of data, and it becomes a challenge, both not just in the hosting, but also in serving it up where a lot of people could access it very effectively without getting bogged down.
Yeah, and even if it wasn't like you guys hosting it on your servers, if you were sort of a front end to wherever things were, so that people know, like in this space, you go to SimTK and they can hook you up and they can make that project page, have access to all this stuff, could be very useful.
Yeah, so I think the question we've had is, like, could we be a front end for Google Drive or some other space that actually hosts the data, and then just provide a standard, I guess, way of sharing. So one thing I'll mention, for Matt to do the query, he needs to provide metadata in a certain format. And I think that's one of the things with the biomechanics community that we don't quite have yet, is some standard for sharing metadata. And what metadata is more important. I don't know if you have a webinar coming up on that. I'd love to attend, Matt, if you do.
I think we should. So
that might be an idea for a future speaker as well. So thanks. Yeah, I'd love to talk to you more as well.
Thank you, Joy.
Definitely don't want to take any airtime from anybody who wants to talk, but Rob, I just wanted to say you have such a pertinent point that the parsing and the standardization of data that goes into a repository is more of a hurdle than accommodating size or being able to collect that data. One of the reasons that we feel equipped in a way to try to create a mechanism for hosting this information is a collaborative grant that's gone on internationally with Kitware, and we have developed software and documented standards for our data. That was, a 3-year initiative, and on the end of that, then we felt, okay, now we actually have at least an in-house or within the 4 collaborative institutions involved in the grant, a foundation upon which we are going to generate a standard from, to represent this data. It's a very difficult problem. So, I mean, Joy, if you're asking for additional affiliations, plugins, associations, I think that the parsing, the front end of getting your data into a digestible format, coming up with YAML files and JSON formats to parse that metadata and link it to your tangible raw information. I'm in the weeds of that with our CCV, the Brown computing and visualization parameters. And it's not a small task. So just hosting that data means you've done all the pre-processing. And so that's a big undertaking.
Yeah, Amy, that's huge. And I applaud you for getting deep into the weeds into that process. We have it through the Stanford lab here at, or the DELP lab here at Stanford. In addition to OpenSim, we've created an ad biomechanics platform, which the idea is to help standardize, at least for the OpenSim types of simulations, to help standardize some of the data that comes in experimentally. And we have people upload, and in theory, things should come out and be in the set format for OpenSim, so you could standardize it all. What we realized is when you go in manually, there's a lot of differences in quality of the data that comes in. And so even though it can pass through the platform automatically, when you go to try to harmonize, there's discrepancies that come up. And so you still need to go in and manually curate, and that takes a lot of time. And so trying to come up with more automated ways to streamline that process, I think would be helpful, not just to our group, but to a lot of researchers. And I think it makes it easier for us as a community to start building these larger data sets that we want to be able to do and ask the questions of machine learning algorithms. So I take both your points, to heart, that this is really a tough challenge, but I think it is a critical point and something we need to address as a community in order to take advantage of some of the new technologies coming out.
Any other questions? Oh, please go ahead, Joy.
No. These discussions are good. I just wanted to wrap up quickly. This is my last slide before my acknowledgements, and we've got a couple minutes. So I just want to mention that some of the things we're working on as we're thinking to these next steps, I think it's important as we talk about connecting to these various platforms to have an application programming interface. The graphical user interface is nice. It makes it very easy for users to get started. But for moving large data sets, for doing things programmatically in more automated fashion, you need an application programming interface to talk to the different platforms. And we've got a prototype that we've been working on. The URL's there if you want to take a quick look at some of our initial calls that we're implementing. The other piece is streamlining the workflow, which we've talked a little bit about what's in that workflow. One of the things that we've done is for the metadata file that Amet's created to make the querying possible. He's created those manually, those metadata files. We recognize that a lot of researchers put all their information about their subjects in an Excel spreadsheet. And so we've made it a way where you can grab that spreadsheet, drop it into the data share, and click a button, and it will automatically parse that spreadsheet and create those metadata files for you. As we think going forward, how to streamline that workflow, I've heard things about wanting to, better ways to harmonize data and streamline that piece of it. You can imagine that as you're pulling in information, it's coming not just from a different software platform, but from an actual piece of equipment. And if there's ways to grab that information and automatically have that appear in a certain way within your repository, I think those are all helpful in terms of making it easier and lowering that barrier for people to get data, get their models into a format that's shareable and reusable. So with that, I want to thank you all for your time, for the great discussions. I don't know if we have time for more questions. If you want to reach out to me in the future, my email is there at the bottom, joyq@stanford.edu, and thanking our funding sources from the NIH and for the DELP lab.
Thank you, Joy, so much. And thank you for your help, to all of us, through the years. Any burning questions? If Joy has time, I have time. So.
Let me double check.
Yeah.
I think I have I have probably about 15 minutes before I have to jump to my next meeting. So
Okay.
happy to continue the conversation. Love hearing about what you all are doing and some of your needs.
And while people are thinking, I will also recommend, if you like this webinar, come back again next month. We will have the Knee Hub group talking about knee modeling workflows and how different workflows may result in different things, even on the same knee. But I will also ask all of you, if you wanted to hear about something that we may not be paying attention, or if you wanted to talk about some resource, some expertise, some exciting things that you want to talk about related to computational knee biomechanics, we are happy to get you on the schedule. Just let us know. And with that, I think we can adjourn.
Thank you.
Thank you very much.
Thanks.
Thank you.
Thank you.
Thank you, Joy.